one of the big projects that can be done by our species in the near future is the space elevator, to allow us to explore space um, with in a new way, allowing us to be able to get outside of the Earth's atmosphere more effectively, and to be able to develop to develop technologies in outer space outside of our atmosphere more quickly, and so that we can expand our and colonize larger parts of our solar system. The space elevator in general has been considered by many of our brightest minds to be impossible at this point in time because of the limitations on our materials. I guess some of the strongest materials would be carbon nanotubes, or a carbon nanotube fabric, and the consensus is that we would not be able to. We cannot develop a material that is strong enough to build this space elevator. So I wanted to just mention a strategy that I discovered at one point when I was submitting proposals to the National Science Foundation, in which the people who were reviewing the proposal, although they rejected the proposal in which I was trying to present an energy system, they did see where there was the strategy I used helped to basically decrease the amount of energy that is needed to do a task. And this strategy is basically the strategy of dividing the labor up into smaller parts. And the way it would look in this example of a space elevator, instead of having a giant cable connecting the surface of the Earth out into space, where there's a lot of attention on that cable, what you do is you have hundreds of thousands of cables that are interconnected, where every section is being maintained, where the mass of that section is being maintained by a robotic system that is interconnected to other sections that are being maintained by robotic systems. So you're dividing up the labor, where basically you have robotic systems that handle every node, every section on that circuit. Because this is a circuit, it would actually be a power distribution model, in which you would have power generation that's going onto this cable, this system, where there's different parts that are interconnected, that are powering the robotic systems that are maintaining that vertical elevator. And so if you want to imagine a prototype, the prototype would basically consist of a modern quadricopter that is powered by an electrical cable that you can plug into an outlet. And so that quadricopter should be able to basically be propelled for a long period of time, because it's no longer dependent on a battery, although a battery backup might be good to handle power outages. And so then the task would be, there would be a lot of smaller tasks that would be needed in order to allow these many, basically a swarm of robots, to be able to work in concert, to work together, to be able to extend that power line. And it becomes a very complicated problem that can be solved, as each mechanical system that's applying some kind of force against the gravitational force of the mass of the line, of the power line, and the mass of the robot, and whatever, you got to have a delivery vehicles and everything upon that entire system. It just becomes it's a problem that can be solved, because you're no longer limited by the strength of the strength of the material needed to have a tether, an enormous tether from way out in space, connected to the surface of the Earth. And what you've done is now you have hundreds of thousands of smaller tethers that are being maintained by robotic systems that are receiving their power from the tether itself, and they interlock together to form this network, this power distribution network that goes vertical straight up into the atmosphere. So it'd be a really cool project to develop, and that is how I envision the space elevator coming into existence as soon as possible. Let me know if you have any questions.